Thank you.
Hi.
I've met you before.
You have. Yeah, how are you?
I'm good.
Yeah, so come on over. Yeah, so I'm Sean Newell, and I lead sustainability technology for the company, and I'm going to talk through three things at this station.
Remind us again, how long have you been with Chemours?
Chemours started in 2015, so I've been there since the beginning in 2015.
Right. And then when you were you at DuPont too?
I did work
How
for
many
DuPont
years have
previously.
you been there?
Yeah, so I'm a chemical engineer, and I started work in 1999.
Hi.
Hi.
What's your name?
I'm Broderick Locklear.
Yeah.
I'm one of the engineers at the Fayetteville Works.
Yeah. How long have you been working with DuPont and Chemours?
I've been at the site since 1996.
You're welcome. So we're going to talk about three things here. One is the progress at the Fayetteville site versus some of our company goals. We're also going to talk about the expansions that are planned in the units and how we're going to go about that. And then the third is going to teach you how we're able to do those expansions in a way that's emissions neutral from a fluorinated organic standpoint. The next table, Crystal will get into the permitting process and how all that will work, and to give you education on that. So the first, to start here, I know you've heard about our company level goals, but I want to talk about Fayetteville, and that's relevant for the rest of the discussion. So two of the goals I'll mention from our corporate responsibility commitment. One of them is to reduce fluorinated organic emissions by 99%. You've heard about that. Another one is to reduce greenhouse gas emissions by 60% by 2030. And on our way to net neutral by the year 2050 is our goal. At Fayetteville, we have achieved the 99% goal for fluorinated organic compounds. We have reduced emissions by 99%. We've also reduced greenhouse gases by more than 85% at the plant. So to put that in perspective, it's about 500,000 metric tons of CO2e that's saved. That's about like taking 100,000 automobiles off the road each and every year, to give you an idea of the magnitude of that improvement. The expansions, moving into that. So the expansions are within the chemistries that we practice today. Amber talked about the monomer plant, which one of the products it makes is relevant for the semiconductor manufacturing. So that's one part of the plant that's being expanded. The other is the IXM or Nafion part of the plant, which is used to make in the green energy market, to make green hydrogen, also to consume hydrogen. That's the other part of the plant. To put it in perspective, so we're not building a whole new plant asset here. In each of these units, we're modifying or touching about 10% of the equipment in those facilities, just to give you an idea of how much it is, how big much of the plant it is. And so now, how are we able to do this in a way that's emissions neutral? So I'll first talk about how did we achieve this goal to begin with, and continue to make progress against that. So there's three categories that I think about when we've reduced emissions of fluorinated organics. The first one is recycle or reuse. So if you can keep the material in the pipes, that's better, or if you can take it and reuse it in the process, certainly that is the best way to deal with it. Or take it and maybe make it into another compound, convert it into something that's useful. That's something we've used, that principle company-wide, as part of our goal. If we're not able to achieve that, the second priority would be to use thermal destruction. So to destroy the fluorine-carbon bond. And so at Fayetteville, that's what you've heard probably about the thermal oxidizer, and that's what it does. It destroys that fluorine-carbon bond at very high efficiency, so greater than 99.999+% efficient to what's routed to it. So that's an effective way to deal with it. The third way is if we can't feed it directly to that unit, is to capture the compounds on something like carbon or ion exchange, such that it can be thermally destroyed at a later step. Still using thermal destruction, but sometimes we have to capture it first and then thermally destroy it. And that's how we've met the goal so far. And still learning and making progress every day at the plant. So how do we use that in this expansion? So there's three ways with this expansion that we're able to come out emissions neutral, even though we're having more throughput. The first category is, I talked about how we're touching about 10% of the equipment. So when we do that, using our experience, there's process steps that we're able to make it have a larger throughput, replacing the vessel, but yet it has a less potential to emit, meaning that we can make more but less emissions from that particular process step.
A quick question. When you say you're touching less than 10%, can you explain a little more what that means?
Yeah, like if you're replacing, if we have to replace a vessel that isn't large enough for the new capacity, we might have to replace the equipment. So that'd be part of that 10%.
So you're saying,
maybe
okay.
we have to modify it.
So you're going to make a 10% modification to existing equipment? Is that a fair
It's,
understanding?
if you think of all the equipment
Yeah.
in the monomers unit,
Got
for
it.
example, we will be modifying or replacing about 10% of that equipment, of the equipment that's there. That's how I think about it.
Okay, thank you. I just
So
wanted to-
It's a
yeah.
fine question. Yeah. So let's see. Where was I?
Sorry.
That's okay. Yeah. The second way that we are able to reduce emissions is by reducing the number of connections and flanges in the plant. So every time you have a flange or a connection, that's another really small potential for emitting. That's some of what's left in the less than 1% that's left is coming from that. So in the new assets, going back and reducing those connections to the extent possible is another way that we're reducing emissions with the asset. The third way is to make offsetting investments in other parts of the plant. So ways where we've operated this abatement equipment for a few years now, and we've learned how to use it in more effective ways, and we're always looking for ways to reduce emissions and taking advantage of some of those and implementing those with the expansion, offsetting emissions. That way, when we're done and we've expanded, we will be able to do so in a way that's emissions neutral from a fluorinated organic standpoint. We're also working on ways.
Why is it significant? I'm sorry, you said fluorinated organic standpoint.
Yeah.
Is that why such a distinction there? Are there other emissions that are?
Well, just what's important for this goal. Crystal actually, she'll talk about
Okay.
everything else,
Okay.
emissions wise as
Okay.
well. But I'm just speaking to this particular goal.
Thank you for clarifying.
Yeah, sure. The last thing that we're working on, I talked about our goal to be carbon neutral by 2050 company-wide with our manufacturing operations. It's working on ways, how can we offset our carbon footprint with this expansion? So when you talk about greenhouse gas emissions, you count any emissions you may have. You also count what's called scope 2 emissions, which is emissions that are the electricity that you're purchasing and using or the other utilities. How can we work to offset those? And so we're working on that now. What are our plans? How can we work to offset that to be able to work more towards our goal? Okay? What other questions might you have?
Trying to think through it. I guess when you say greater than 99%, what do you mean by that?
Versus our corporate goals were set in 2018, so that's a reduction versus the baseline.
And then, what is it going to take to get to 100%?
Yeah, the continuous improvement I talked about, right? We're learning, new ways every day, reducing connections, learning new ways to use our very efficient abatement technology. So we're,
And you're
working
trying
our
to
way.
get there, or is it like, well, we got to 99? So.
We are working to improve every single day at all of our assets, right? We have not, we've not achieved this company-wide, so we're working on it at other sites. We're continuing to leverage technologies and, making the improvements that we can.
I have a project going in next month to help exactly with that.
We're waiting on the next crew.
Crystal's next. What she's going to talk about is the permitting process and how that'll work and the timelines and what that looks like, what you might expect to see.
And so, what is your request? Is Crystal the one that can ask or answer? What is the request going to be? Is it going to be 99%, or is it going to be 99.99%, or what is the request?
Of the permit.
The expansion permit.
Yeah, she'll talk about what's the basis, why do we need to file a permit,
Well,
and exactly
is it
how we'll permit.
Okay, I'm trying
That's
to.
right.
Okay, so she's the one that'll be able to answer. Are emissions going to be tracked in terms of percentages?
She'll be able to exactly answer that. I mean, I think we still have more work to do with the DEQ and the permitting process as it goes on, but she'll be able to describe the different steps and what we'll know at what points and things like that. Absolutely.
Thank you. I appreciate your time.
Yeah, good to see you again.
Emily, I'm tapping out.
You getting too tired? That is everybody. You hung in. Well done, soldier.
Good job. Nice